All right, so let's get started. So who is returning? Okay, who is this? Who's this? Like, who's coming for the first time for this workshop? Okay, okay. So for those of you who are, this is your first workshop. You're gonna have to grab the code from the last workshop, and that's on our GitHub page. Um, if you don't know how to use GitHub, that's okay. Um, there's an easy way to get it off GitHub. So I'm just gonna. What's the best way to access our GitHub? It's like super hard to find.
Do you want to post like a link in the Facebook?
Yeah, I'll do that. I know I linked it on the last workshop. So I'll link this in the Slack channel. Okay, yeah. So I guess the best way to find it is to go on YouTube, find Aztec Game Lab, and then the first workshop video should have the link in the description. So okay, so from GitHub, is anybody having issues getting to the GitHub page? Okay, so from the GitHub page, if you know how to use GitHub, you can just clone it to somewhere on your computer. Otherwise, you can click here on clone or download, and then download it as a zip file. And then I'm just gonna set it on my desktop. So once you download it, you can open up Unity here. And then we wait 3 hours for Unity to boot up. Okay. Okay, so let's get started with the actual Unity stuff. Okay, so if you've downloaded this off of GitHub, you're going to want to open the scene we were working on last time. So basically, I don't know if I explained scenes too much last time, but scenes are, you can basically think of them as levels. So when you're playing something like Crash Bandicoot or something like that, when you exit an area and the screen fades to black and it fades back in, you're switching scenes. So it's basically just a collection of game objects. It's a place in your game. So we're able to switch scenes. When you start up Unity, it gives you a blank scene, but we're going to go to the scenes folder in our project menu down here and just double click on main scene, and that'll bring us into the scene we were working on last time. Okay, so first, actually, last time I didn't even introduce myself. I know I did at the beginning of the meeting, but I'm Barry. I'm a third-year computer science student. Just so you know, I'm not just a random guy teaching you Unity. I've used Unity for like 7 years for personal projects, and I've been using it professionally for like 2. This summer, I worked at an AR agency, and I did some work for a Lucasfilms project. So, yeah. So that's me. It's a AR module inside of the official Lucasfilms app. So basically, it was just to show off the new characters for the new movie. Okay, back to Unity. So I'm going to review some of the editor stuff that I talked about last time. First of all, can everybody see my pointer? Okay. Because I know some people were saying that they can't see it. We good? Okay. So we have... So Unity is kind of this weird beast that's got a bunch of different tabs, and they can be in literally any place in the editor. So I usually like to go layout and tall, and that gives you this kind of layout. And then I like to drag my game view right beside my scene view like that. So the different parts of the editor, we've got the game view. This is what your game's actually going to look like when you play it. You've got your hierarchy. In your hierarchy, this is where you see all of your objects in the game. And if you recall from the last workshop, Unity operates on kind of a different paradigm. It's not the object-oriented approach you might be used to. There's this idea of entities and components. We can also call entities game objects. So usually in Unity, people will call these game objects. So you've got your game objects in your hierarchy panel, and game objects have components associated with them. And basically, components are just what let your game objects do things. So in your hierarchy here, you've got your game objects. In your inspector panel, you've got all of your components that are associated with that game object. So when I select a game object, I see its components. So that's the hierarchy, that's the inspector. Then we've got our project panel. The project panel shows you all of the files that are associated with your project. So this is going to be your images, your audio, your scripts. Everything's going to be in your project panel. And something I didn't talk about last time is that this project panel, everything that happens in this project panel is reflected actually in your file explorer. So if I were to go and look at where I unzipped this folder, and I go into assets, I can see that this file structure here, scenes, sprites, scripts, I spelled scripts wrong, it's okay. Scene, sprites, scripts. So all of this is reflected on my actual, in my actual file explorer. So that brings up another thing. If I go into my scripts folder here, I've only got one item. But inside of the file explorer, I've got two. And that's because Unity generates what's called a meta file for every file that you create. Basically, it's just some data that explains this file. You don't have to worry about it. You pretty much never want to touch it. Unity kind of just does its own thing with that. And if you play with it, you'll probably mess something up. So when you're modifying your files, never do it inside of your file explorer. Always do it inside of your project panel. So that's our project panel. And then the last thing kind of on the screen is your scene view. So the scene view, if you recall, is where you can manipulate your game objects. First of all, does anybody have any questions about the editor so far? Are we good?
Is everyone set up with the project?
Cool. Okay. So the scene view is probably one of the more important panels. It's where you can actually manipulate your game objects, move them around. And something I didn't talk about last time is how to kind of navigate in here. So up in the top left-hand corner, you've got your scene view tools. So your first one here is a hand. It lets you drag around the scene. It's pretty self-explanatory. Your second one is your translation tool. So your translation tool lets you move things around. So if I were to click on my paddle, it gives me these kind of arrows. I'm scrolling to zoom in here. It gives me these arrows. And I can pull these arrows up or to the right to move it on the X and Y axis. Or I can grab this box to move it around in both axes at once. The next one is the rotator. So if you grab the outside of the rotator here and pull, you can rotate back and forth. I'm going to Control Z that because we want it to be flat. Scaling. It's really hard to see, but right in the middle there's a little white box. You can grab that box and pull, and that will scale it uniformly up and down. Otherwise, you can scale it on the Y or the X axes like that. Okay, and then the last one is a tool specifically for 2D things. So Unity is a game engine that you can make games for 2D or 3D. And this tool specifically for 2D things like 2D sprites like this, or your user interface, so like your heads-up display with your health or whatever for your user to manipulate things on the screen space. So this tool allows you to manipulate things really easily that are 2D. So you can use that if you prefer. And all of these tools up top are mapped to the Q, W, E, R, T keys. So I can cycle through those with the first 5 keys on my keyboard. So that's the scene view. It's where you spend most of your time, other than probably in your code. So, all right. So I believe that's good for view. Everyone good with that? Cool. Okay. So, one more thing. In our game view, some of you might be having the issue that you're getting this weird stretched out screen that it kind of changes when you move it. It might be too big or too thin. Last time we set an aspect ratio that was nice and tall. So you might have to redo this if you downloaded the project off GitHub. But you're gonna go to your game panel, go up to the top where it says free aspect, or if it has some other aspect ratio, you're gonna want to click here for the dropdown, plus sign, and then change it from fixed resolution to aspect ratio. And we're gonna want this to be 9 by 16. And I've already got that setting here, so I'm just going to select it. That'll give us the nice tall aspect ratio. All right. So last time we got as far as moving our paddle back and forth with our mouse. So everybody should have that. Is everyone able to do that? So if you click the play button, it should be tracking your mouse. We good? Is anyone not good? Okay, excellent. So this time, so we're making a breakout game. So the idea is that we've got this paddle down here, and we want to stop the ball from going off the screen. So obviously we're missing a ball right now. So let's go ahead and start with that. If you remember from last time, we made the paddle by making a sprite for it and then dragging it into the scene. So let's go through the steps for that again to make the ball this time. So if you go into your project panel and you click on your sprites folder, and then you come over here and you right click, create, and then we're going to go down to sprites. And this time, instead of creating a square, we're going to create a circle. And that's going to be our ball. You're going to name it ball. So after you made the sprite, you can just take it and drag it straight into the scene here. All right, so there are a couple ways to actually select game objects in Unity. You can either actually click on the object, or you can click on its name in the hierarchy panel here. So you're going to want to select your ball. And this ball is actually kind of extremely large. So I'm going to select my scaling tool and make it a good size. So that's a good size. Okay, so now we've got to talk about, we have to think about what we're doing here, right? We want this ball to be bouncing around the screen, and we want to be able to block it with a paddle so that it doesn't fall below the screen. In order to do that, we've got to move the ball around. If you remember from the last workshop, I'll just review the transform. So one of the components that's built into a game object is called the transform. So If you select your ball, you'll see the first component up here is the transform. And this gives us information about the position of the object, the rotation of the object, and the scale, or how big the object is. So the way that we moved our paddle back and forth last time is we were literally changing, and actually you can see it. If you select your paddle and press play, you'll see as I move back and forth, the X value up here of the paddle is changing. So if I move it this way, it gets negative. If I move it this way, it gets positive. So it's moving back and forth on the X. So that's how we got the paddle to move last time. There's actually there are two different ways to get things to move in Unity. It's either changing the transform directly or using what's called a rigid body. So a rigid body is a component that allows game objects to, you're basically saying, hey, physics engine, I don't want to deal with this game object, you do something with it. So you can use it to make things fall, make things collide with each other, make things bounce around, and you don't have to write any code for it. The physics engine will do it for you. So we're going to give this ball a rigid body. So we need to add a component to this ball. Who can take a guess on how we're going to do that? Add component, exactly. So if you click add component and we type in rigid body, we're actually going to want the rigid body 2D. So with the physics system, like I said, Unity is both a 2D and a 3D game engine. So they have to separate their 2D and 3D physics. So whenever you're dealing with physics, you're going to want the version with 2D appended to it for when you're making a 2D game. So let's get a rigid body 2D, and then I'll explain some of this. So let's see. So with a rigid body, you can, the most important things here are the gravity scale and the material, which we'll talk about a little later. But the gravity scale basically tells you how fast your object's going to fall. In real life, gravity is going to be 9.8 meters per second squared, but this is a video game, so we're just going to do 1 because it works. So we've got a gravity scale set, so if we press play, we'll see our ball fall. So does everybody have a falling ball? Sweet. Sweet. Okay. So that's half the battle. So we've got our game object moving, but now, I mean, we've got an issue here. Our paddle doesn't do anything; it just falls straight through. So we've got to make these objects collide with each other. So rigid bodies allow things to move around with a physics system. There's another component that allows things to collide in the physics system, and that's called a collider. Go figure. So we're going to select our paddle. You can either select it in the hierarchy or you can click on it. And then in the inspector window here, we're going to add another component, and this time we're going to add a box collider. And remember, we're making a 2D game, so it's going to be a box collider 2D. So box colliders, so there are a lot of different shaped colliders. They all do the same thing, they collide. And they all pretty much have the same parameters down here. The only one we're really going to worry about here is the material, and again, we'll talk about that a little later. We don't have to mess with any of these settings. Our panel should have, or our paddle should have collision on it. So when we press play, oh no, we're still falling through. So this is because you could have guessed this, but it's because you need to make sure that if you want two objects to collide, they both need to have colliders on them. So if we go ahead and select our ball in the hierarchy, or we click on it, add component, and this time let's use a circle collider because it fits the shape a little bit better. Actually, if we if you make sure your ball's selected, and you click the F key while your mouse is while your mouse is inside the scene view here, you'll focus in on the circle. And I don't know if you can see it. Oh man, the color's really bad. But there's a very faint green circle around our ball here, and that indicates that we've got a collider on it. So the same thing if you were to select your paddle and press F, you can see that green outline indicates that you have a collider on it. One thing, side note, if you look in your inspector panel, each of your components have a checkbox by the name. If you uncheck that, that will turn the component off. So if there's a component you don't need right now, you can turn it off or turn it back on. So if I were to uncheck our paddle controller from last time and press play, it will just do nothing. So, oh, spoilers. Okay. So we added our circle collider. Yeah, spoilers. So if you press play, your objects should collide. So great, we're making progress. We've got a ball, it drops onto the paddle, but now we want it to bounce around, right? So this is where the materials come in. So the physics system doesn't know if you want a bouncy ball or a ball that has a lot of friction or a ball that slides a lot. By default, it just makes it not bouncy and not slide. So in order to kind of describe the type of physics behavior that we want, we've got to use this thing called a physics material. So a physics material is just going to be another type of asset. So if we go to our project panel and we right-click in the empty space, we're going to create a physics material. Remember, whenever we're working with physics, the physics system in Unity, we want to specify that we want a 2D. So physics material 2D. And we'll call this ball material. All right. I just named it ball material. You can name it what you want, but okay. So when you click on that physics material, you'll see in the inspector there are a few different options. There's friction and there's bounciness. So we want our ball to bounce around, and we don't want it to be slowed down by friction. So we're going to make the friction 0, and we're going to make the bounciness infinity. Just kidding, we're going to make it 1. Bounciness of 1 will just make it so that it never slows down. So now we have to actually assign that material to our ball. So if you select your ball, we're gonna assign our ball material to the material inside of our circle collider, like that. Does all this make sense conceptually to everybody? Yes? All right, so once we assign that, we should be able to press play and see some bouncing. Let's see. Hey, is everybody getting that? So we're kind of halfway there. So if you're familiar with Brick Breaker, we kind of don't want the ball to be falling down off the screen. It just needs to bounce around. So we probably don't actually want gravity. So in order to turn the gravity off, we're going to select our ball, and we want to change our gravity scale to 0, and that will make it so that we're still getting the physics engine acting on the ball, but since there's no gravity, it's not going to move when we start. So if we press start, our ball doesn't move, which is what we want. at this point, we're going to have to write a little bit of code in order to get the ball to kind of fly around. Has everybody got the gravity thing down? Okay. So the next part is, the next thing we have to do is involves a little bit of math. So you'll find as a game programmer, you use a lot of linear algebra. So who here has taken linear? Okay, that's not a lot of people. That's fine though. It's very simple linear, and you probably done this type of stuff in high school. But who's familiar with the idea of vectors? Vectors? Okay, so let's go over that. Basically, a vector is defined as a some magnitude and in some direction. In other words, if you imagine your good old Cartesian grid, if you have a Cartesian grid like this, a vector, a vector is just some direction like that. So if we've got, and it's defined by its components. So if we've got something like this, where we've got a vector that's 1 in this direction and 1 in this direction, we can kind of, we write that vector like this. So it's 1, 1, or like this. Sorry, 1, 1. So in Unity, we have this idea of a vector 2. This is a type. So it's just like a container that contains 2 numbers, and it represents a vector like this. Does everybody understand that? Yes? Yes? Okay. So we might have a vector. So this vector is not 1 unit in length, right? If you remember your, this side is x, if you remember your high school math, we've got something that's not 1, and that's not what we want, right? Well, that's not what we're going to want because, sorry, let me take a step back. We need to understand vectors because we need to give our ball a direction to move in, right? So we can do this with vectors, and if we have a vector that is, if one side is square root 2 over 2, one side is square root 2 over 2, this math, don't worry about the math, just so long as you understand the concept. Then we've got a unit vector, or it has a length of 1. And that's what we want, so that when we multiply this vector by some number, say we've got a speed, when we multiply this vector by our speed, all it does is stretch the vector out. So instead of being 1 unit in length, it becomes 10 units in length. And we can only know exactly how long the vector is going to be if we know that it's 1 unit in length to begin with. Does that, we all good with that? Can we accept that to be true? Okay. So if we've got say we've got a vector that's 3 units long. Sorry, okay, so what we're going to want to do is we want the ball, when we start up, we want the ball to move in a random direction to start the game. And in order to do that, we have to first pick a random direction. So it might be this way. And then we take that random vector 2. We take that random vector 2, and then we do what's called normalizing to it. So if we've got a vector and we don't know how long it is, we can normalize it, and that will basically cut the vector down to be 1 unit in length. If you don't totally understand that, that's okay. You'll kind of gain an intuition for it the more you do it. So let's just first of all, is there any question? Are there any questions about that? Please let me clarify that more. Yeah, so a vector, basically our vector is going to give us a direction that we want the ball to go in, right? And the magnitude of the vector, or the length of it, is going to be how fast the ball's actually moving. Cool. Cool. Okay. So back into Unity land here, we're going to want to select our scripts folder, and we're going to make a new script. So like I explained the last workshop, scripts are how you create new components. So it's how you add functionality to a game object. So if we go to create and we create a new C# script, we'll rename this one ball controller. Mention names. Oh, yes. So first of all, your names have to be no spaces. They can have characters, but make sure you don't put spaces in your name or Unity will yell at you and your code won't compile. So you can double click on that script to open up your IDE. If you're on a Mac, you probably have mono develop. That's okay. The steps should be pretty much the same. Good. Okay, so who remembers what these functions do? So these are the default functions that you get when you make a new script. Okay, so start fires one time when you start up your game. An update is called continuously a lot of times per second, very fast. So all we want to do with the ball is send it in some random direction when we press play. So that code's going to go inside of start. So we don't need develop for that, or for update for this. So we're just going to get rid of it. So in order to get our ball moving, recall that there are two different ways to move things around in Unity, either by changing the transform directly or giving it a rigid body, which will kind of hand it off to the physics engine and it'll do its thing. So if you recall, our ball is using a rigid body. So we don't want to change the transform directly. We want to tell the rigid body what to do. So first, in order to tell the rigid body what to do, we've got to get a reference to the rigid body. In other words, we have to specify that we're working with that rigid body. So we're going to start by having a rigid body 2D, right? So this is the same type as our rigid body 2D here. We're asking for this in our code. So rigid body 2D, I'm just going to call it rigid body. And this next part, if you're not very versed in programming, that's okay. Just go with it, and you don't have to understand exactly what it's doing. But we're going to call a function called getComponent. Yes. Did I? That's an equal sign. It just looks terrible on the monitor. Yeah. Is that better? Yeah. Yeah. Okay. Sorry about that. So, so we're gonna set this rigid body equal to, and then we're gonna call the function getComponent, and inside of the less than, greater than, rigid body 2D. So let's break this down. We're making a new variable. Its type is a rigid body 2D. So its type is this rigid body 2D. We're naming it rigid body so that we know what it is. And then we're using the function getComponent. So what this does is, okay, so we're inside of our ball controller, right? That's going to be attached to our ball. What getComponent does is it looks through all of these components that are on the object, and it tries to find one of this type. So it's going to look through, it's going to say, this is not a rigid body 2D, this is not a rigid body 2D, this is a rigid body 2D. So it's going to return that. So it means it's going to set our rigid body equal to this rigid body 2D, the specific one. So we're getting a reference to our rigid body. Does that track with anybody? Everybody? Does everyone get that? Cool. Okay. So now this is where vectors come into play. They're really not as scary as they sound. We're going to make another variable. It's going to be of type vector2. And this is going to be our random velocity. So we're going to get some random velocity. It's going to go in some direction, some random direction. And how we want to do that, in order to initialize a vector2, it's going to be new vector2. So most of you are probably new to C#, but this is the same thing as Java, basically. So your new operator just says, hey, I'm going to make an instance of vector2. It's just making a new vector2 and assigning it to random velocity. So we can actually assign the two floats inside of our vector2 inside of the parameters for vector2 right here. So we're trying to get a random velocity, right? So we need to generate two random numbers. So the way that we're going to generate random numbers in Unity is a class called random. So it's capital R, random, and then there's a function inside of that called a range. So what this does is it's going to give us a random number within the range we specify. So we're going to want this to be between 0 and 1. And then, so this part is our x component. And we're going to actually want to do that again for our y component. So it's going to be another random dot range, not random range, random dot range, 0 to 1. Okay, so that's going to give us, let's take a step back and look at what's going on here. We're making a new variable of type vector2. It's named random velocity. And we're assigning it to a new vector2. The x component is random between 0 and 1, and the y component's random between 0 and 1. So what that is we're saying, give us a random x value between 0 and 1. So random between 0 and 1, and then y is also random between 0 and 1. And then we're putting it into a vector so that our vector is going to be over, oh Jesus, give me a line, over a random x. So it's going to move over x units. It's going to move over x units, up y units. These are both random, and that defines our vector. So that's what vector 2's are for. And this random x and random y is going to tell us which direction our ball is going to shoot off in. So if we generate like if we generate 0.5 and 1, we might shoot our ball off in this direction up this way. So there's one more kind of caveat to this. Another kind of programming concept is that there are two different functions called range that take different parameters. So one of them takes ints and one takes floats. We want the one that takes floats. And in order for Unity to know which one we want, we just put an F after our number, and we'll know that they're floats. Cool. So that's going to create a random velocity. So there's another concept that I went over with the vectors, and that's normalization. So does anyone recall what normalization is? Okay, I'll explain it again. Basically, if we've got a random vector here, we have no guarantee that the length of this vector is going to be 1. We don't know what the length of this vector is going to be because x and y are random. What normalization does is it stretches your vector out or shrinks it, whatever it needs to do, in order to make this unit length or give it a length of 1. So if you don't quite understand that, again, it's okay. It'll come with practice with vectors. But that's going to be random velocity. We're going to do random velocity dot normalize. And that's a function. So it's going to be parentheses after it. And that's just going to make it so that when we multiply this by however fast we want the ball to go, it'll give us a consistent speed. Okay, so there's one more step here, and that's giving it some speed. So right now, if we were to set the ball off with this velocity, it would go 1 unit per second, which is extremely slow. So let's just do random velocity equals itself random velocity, but times 10. So we're going to make it 10 times faster. You can also write times equals if you want, but this works fine. So if we switch back over to Unity, if you select your ball and you take your, make sure you're in your scripts folder, select your ball, and then drag your ball controller over to here until you see this kind of blue line here, and then set it in there. And that will assign your ball script to your ball. Otherwise, you can also drag it onto the ball in the scene view. Either way works. And when you press play, nothing happens. Woo! So we've got one more step. Does anybody know what that might be?
Assign it to rigid body.
Exactly. So now we've got a reference to our rigid body, and we have this random velocity. Now we actually have to tell the rigid body, hey, move with that velocity. So that's going to be rigid body dot velocity equals, I promise that's an equal sign, random velocity. And now make sure you save your scripts before you switch back to Unity, or else it won't compile. When you switch back to Unity and you play, oh my god, that was fast. Let's slow that down a tiny bit. That was really fast. So you can change this variable to make it faster and slower. Actually, you know what? Let's go ahead and make a global variable. So we'll call this. First of all, is everyone tracking with this? Are there any questions? Yes, you could do that. And that's kind of something I wasn't going to deal with today just because, no, it's totally fine. Because normalizing a vector will give it a length of 1, but depending on the system, it will also make it positive. Yeah, so it's going to be positive anyway. But yeah, but it's fine. It's a good to know. So, oh yeah, when you're making a game, there are a lot of parameters that might need to be changed quickly. So you don't want to go back to your code and change them every time you need to tweak a little thing. So you can actually expose those in your editor so that you don't have to leave Unity. So in order to do that, we'll make a global variable. So it's going to be public. We'll make a float. And we'll call this speed. And let's set it equal to 5 as a default. So now we're going to, instead of hard coding a 5 down here, we're just going to say speed. So we save that out. And when we go back into our editor, we'll see the speed show up under our ball controller down there. So is everybody seeing that? So now, instead of having to go back into code to change how fast our ball moves, we can just set it in here. So now, if we press play, our ball is moving at a pretty reasonable speed. And it's a random direction every time. All right, so there's kind of just one more thing. So right now our ball is flying out into the void, never to be seen again. Let's fix that. So we can make boundaries on our screen by making another collider, basically. And this is a different type of collider. It's called an edge collider. And in order to make our edge collider, we've got to make a new object. So this time, we're going to be creating a new object, but this time it's going to be inside of our hierarchy. So in some empty space in your hierarchy, you're going to right-click and create empty. And then this is kind of weird. In Unity, if you want to rename things, you can do a slow double-click. And that will allow you to rename it. Or I believe you can right-click and rename. Yeah. And we're going to name this bounds. Yeah, so if you accidentally had something that looks like this, just grab your bounds and pull it out here. So it's not a child. And we're going to want to make sure that our transform for our bounds, our position is zeroed out. So we're going to make sure we have 0, 0, and 0 here. I don't know how much you guys can see because the resolution is really bad. That says bounds right there. Okay, so we want to add a new collider. Who can tell me, other than you, I forgot your name. What's your name? Dwayne. Other than Dwayne, who can tell me how to add a new collider? Yes. Yeah, so add component. And you can search these drop-downs. It'll be physics 2D. And then we want an edge collider this time. Or you can just type it in. Edge collider. Okay, so edge colliders are unique in that they allow us to make shapes that aren't built in. So we use the box collider and the circle collider. This one's for obscure shapes. So if we select our bounds, we put our mouse in our scene view and press F. That'll focus in it. I'm going to scroll a bit to zoom in. And it's kind of behind our camera, but you can see a green line there. And if we go up to, if we select our bounds and we click on Edit Collider here, you'll see it clearly. We've got a green line right here. So this is our collider. If things run into this, they're going to be blocked. It's part of the physics system. But the special thing about edge colliders is we can grab the ends of it and manipulate it. So we're going to go ahead and grab all the way at the end and position these at our side here. And then if you grab somewhere in the middle and move it, it's going to break it into another segment. So we can just do this to kind of line the screen. And we don't want to line the bottom with the collider because we want the player to be able to lose and the ball to go out the bottom. So now we've got a collider where if the ball hits the sides, it'll just bounce off. Yeah, so now if you click play, then you should have a little kind of a Pong breakout game going. Woo. So real quick, any last questions about this section? Does anybody have any questions about this section of the workshop? Nope. All right, so next time we're going to be adding bricks and destroying them, and just like little things like that, just building on kind of what we talked about so far. And for the last lecture, or the last kind of workshop in this series, I'm going to go through and add a bunch of effects and stuff so that you guys can see what you can add to your game. And I'll show you some techniques that you can use, like screen shake and particle effects and stuff like that to make your game feel juicy. So we've got 2 more of these. And yeah, so that's about it. You guys